Hello children, welcome to aimsindia online classes. This is a chemistry session. In this, we are discussing about the chapter atomic structure. In this session, we are going to see about different models of atoms proposed by scientists like Bohr's model of atom, Sommerfeld's model of atom, De-Broglie's wave theory. About these concepts, we are going to see now. Let us see first about Bohr's model of atom. In 1913, one of the Rutherford's students, Niels Bohr, proposed a model of atom that was consistent with the Rutherford's model and the quantum theory of radiation. Yes, in 1913, one of the Rutherford's students, Niels Bohr, proposed this model of atom, which is consistent with the Rutherford's model, means it is supporting some points, assumptions from the Rutherford model, as well as even the quantum theory of radiation also. He modified the problems and limitations associated with Rutherford's model of atom. Yes, as there are some limitations and drawbacks in the Rutherford's model of atom, he modified those concepts or assumptions which are there in the Rutherford's model. Let us see the postulates of Bohr's atomic model. Electrons move around the nucleus in specified circular paths called orbits or shells or energy levels. Yes, electrons are revolving around the nucleus in fixed paths, fixed specified imaginary paths. Those imaginary paths where electrons are revolving around the nucleus of an atom are called orbits, shells, or energy levels. See here, suppose if it is an atom, the total number of protons and neutrons are located in the center. So in these points, in these aspects, it is supporting Rutherford's model of atom. As he said, protons or neutrons at the center, which is called the nucleus. Electrons are revolving around the nucleus in the imaginary paths, fixed imaginary paths called orbits, shells, or energy levels. Each orbit or shell is associated with a definite amount of energy. It is fixed for the electron which is in the particular orbit. Hence, these are also called energy levels and are designated as K, L, M, N and so on respectively. As each orbit is prescribed, associated with a definite amount of energy. Means if an electron is present in particular orbit, it will be having certain fixed amount of energy in that orbit. As it is defined here, the orbits are also called as stationary orbits or energy levels, and even they are denoted with the symbols K, L, M, N and so on. The shell which is nearest to the nucleus is denoted as K, and as we move away, the names are given like this: K, L, M, N, O, and so on. The energy associated with a certain energy level increases with the increase of its distance from the nucleus. Yes, the orbit or energy level which is nearest to the nucleus is having the lowest energy. That means K shell, that is first shell, is having lowest energy among all. And the as the distance between the nucleus and the energy level increases, the energy associated with that energy level also increases. As the distance from the nucleus increases, energy associated with that energy level will be increased. Hence, if the energies associated with the shells K, L, M, N are E1, E2, E3, E4 respectively, then E1 is always less than E2, E2 is less than E3, E3 is less than E4, and so on. So the energy of the energy associated with the orbits increases as the distance between the nucleus and that energy level increases. The lowest energy level is the first one. The energy level which is very near to the nucleus is having lowest energy. Okay. As long as the electrons revolve in a particular orbit, the electron does not lose its energy. Therefore, these orbits are called stationary orbits, and the electrons are said to be stationary in energy level or in stationary energy states. Yes, whenever electron is revolving in a particular orbit, its energy neither lost nor gained. Its energy will be fixed until and unless it is being jumping to another orbits. If it is revolving in a particular orbit, its energy will not be changed. That is why these energy levels are particularly called stationary states and stationary orbits, and these electrons are said to be in the stationary energy state. Okay, an electron jumps from a lower energy level to a higher energy level by absorbing energy. It jumps from a higher energy level to lower energy level by emitting energy. These two will be occurring in the form of electromagnetic radiation. Okay, as we told, whenever electron is revolving in a particular orbit, its energy will be fixed. It won't gain energy, it won't lose energy. When it jumps from one orbit to another orbit, energy changes occurs. Suppose an electron is jumping from lower orbit to higher orbit, then it absorbs some energy. If it jumps from higher orbits to lower orbits, then it emits certain amount of energy in the form of electromagnetic radiation. Okay, the energy emitted or absorbed is given by Planck's quantum equation, which is called delta E is equal to h nu, where this delta E represents the energy emitted by the electron when it is jumping from higher orbit to lower orbit, and this h represents, as we know, Planck's constant, and this nu represents the frequency of that energy emitted by the electron. Okay, so delta E is equal to h nu. For example, if E1 and E2 are energies of the first and second orbits, then difference in energy is equal to h nu. That is E2 minus E1 is equal to h nu. Okay, that means when electron jumps from second energy level to first energy level, then the amount of energy released will be equal to h nu. The electron can revolve only in an orbit in which the angular momentum of the electron is a whole number multiple of h by 2 pi. Actually, it is 2 pi. It is by mistake, it is going to be, it is 2 pi. So angular momentum, we know momentum means mass into velocity. As electrons are revolving in a circular path, their momentum is said to be angular momentum. So the electron can revolve only in an orbit in which the angular momentum is integral multiple of h by 2 pi. This is known as principle of quantization of angular momentum. So for electrons, angular momentum is quantized. For orbits, quantized. So electrons will be revolving in those orbits where angular momentum of that orbit will be equal to multiples of h by 2 pi. Hence, we can write angular momentum of the electron as mvr is equal to nh by 2 pi. We told angular momentum is equal to multiples of h by 2 pi. So h by 2 pi into n. It can be commonly written as mvr is equal to nh by 2 pi, where this n is a integer which represents the orbit number or principal quantum number, the number of the orbit in which the electron is present, and m is the mass of the electron, v is velocity of that electron, r is the radius of that orbit in which electron is located, or distance of the electron from the nucleus. Both are same. So the distance of the orbit from the nucleus, nothing but it is radius of that orbit. And as we know, the remaining two, h and pi, these two are constants here. By applying the concept of quantization of energy, Bohr calculated the radius and energy of the electron in the nth orbit of any single electron species like hydrogen atom. So these two are given as follows. Yes, for any single electron specific atoms, we found the energy and radius of the orbit in which the electron is located. These two are given certain equations. These two are calculated by Niels Bohr. He given the equations for these in this way to calculate the energy of the electron and the radius of the orbit in which electron is located. For example, radius of the nth orbit can be calculated by using the formula radius of nth orbit r is equal to 0.529 into n square by z in angstroms. This gives the radius of the orbit in which the electron is located in a single electron species. Okay, next energy of the electron in the nth orbit, where n is the number of the orbit and z is the atomic number of the single electron species. Yes, here n represents the number of the orbit and z represents the atomic number of that single electron species. And energy can be calculated. Energy of the nth orbit can be calculated by using the formula E of energy of nth orbit E is equal to minus 13.6 into Z square by N square electron volts per atom per ion. Okay, this is the formula to calculate energy of the electron in the nth orbit. In this way, the formula the quantized formula for the radius and energy of the electron in the nth orbit of single electron species was given by Niels Bohr. Radius can be calculated by using the formula Rn is equal to 0.529 into n square by z in angstroms, whereas the energy can be calculated by using the formula minus 13.6 into z square by n square electron volts. Okay, these are the formula given by Niels Bohr. Even though these all of the much clarity is given by Niels Bohr, there are some drawbacks or defects in this theory also. Let us see those. Bohr's theory could not explain the atomic spectra of higher elements or the elements with more than one electron. For example, atomic spectra of helium, lithium, beryllium, boron, carbon. These atomic spectra were not explained by Bohr's theory. Bohr's theory is only limited for the single electron species like hydrogen and hydrogen like ions helium plus, Li plus 2, Be plus 3. For these only it is limited. For single electron species only it is applied. For the multi-electron systems, this Bohr's theory is not applied, or the atomic spectra of these elements could not explain by Bohr's theory. Bohr's model could not explain even hydrogen spectrum obtained using high-resolution spectroscopes. Each spectral line on high resolution was found to consist of two closely spaced lines. Yes, actually in Bohr's theory, certain lines were observed when electrons jumps from higher orbit to lower orbits. But when it is observed through high resolution spectroscopes, each line is further finely divided into two or more closely spaced lines. Why these spectral lines are splitting into different lines were now it was not explained by Bohr's theory. It was not explained by Bohr. This is one of the drawbacks. It could not explain Zeeman effect. Yeah, it is one of the limitations or drawback in the Bohr's theory. That is, it could not explain Zeeman effect. This is in the presence of magnetic field, each spectral line gets split up into fine lines. This phenomenon is called Zeeman effect. Yes, actually, when these spectral lines are passed through magnetic field, then these lines finally further splits into fine lines. The splitting of spectral lines in the presence of magnetic field is called Zeeman effect. This could not explained by Bohr's theory. One more, in the same way, he could not explain even the Stark effect also. This is, if the same spectral lines are being split into different fine lines in the presence of electric field also. So in the presence of electric field, each spectral line gets split up into fine lines. This phenomenon is called Stark effect. Even this Stark effect also could not explain by Bohr's theory. So this we can say limitations. One more, Bohr's theory could not account for the formation of chemical bonds. Yes, there is no explanation about how chemical bonds are being formed between the atoms. He could not explain about it. So this commander drawbacks or limitations in the Bohr's theory. Next theory, Sommerfeld's extension of Bohr's theory. Sommerfeld's extension. Arnold Sommerfeld in 1915 extended Bohr's theory and gave his postulates. According to him, the stationary orbits in which electrons are revolving around the nucleus in the atom are not circular but elliptical in shape. It is due to the influence of the certain located nucleus. Centrally located nucleus. Yes. Actually, till Bohr, previous scientists all they have told that electrons are revolving around the nucleus in a circular path called orbits. The same was told by Niels Bohr also. He called them as stationary orbits and they are circular in imaginary paths. But Sommerfeld, the first, he proposed that, according to Sommerfeld's theory, the stationary orbits in which electrons are revolving around the nucleus in the atom, these all stationary orbits are not exactly circular. Some of them are being elliptical in shape. It is due to the influence of the centrally located nucleus. Because of the influence of this nucleus at the center, these stationary orbits are being even in elliptical shapes also. Not all the orbits are in the spherical shape. Some of them are in the elliptical shape also. That is why there occur some energy differences between the electrons, even though they are in the same orbit. That's why there occurs some splittings in the spectral lines in the brains of either magnetic field or electric field. So he has given the answer for that questions where Bohr could not. The electron revolves in elliptical path with the nucleus at one of its foci. So there will be a major and minor axis of the path. Yes, as it is being in the elliptical shape, there will be major axis and minor axis for that path. He concluded that the first orbit is circular in nature. The second orbit has two suborbits. One is elliptical and the other one is circular in nature. The third one has three suborbits. One is circular, two are elliptical. So as the number of the orbit increases, number of suborbits also increasing. Out of them, one will be circular, remaining are in elliptical shape. So according to this, sub-shells or sub-energy levels concept was aroused. So Sommerfeld has introduced this suborbits concept or sub-energy levels concept. So as there are splittings in the spectral lines, he would explain about these spectral lines splitting in the brains of electric field and magnetic field by this conclusion. So in an atom, the stationary orbits all are not in the circular shape. So in an orbit, these orbits are also in the elliptical shape also. Suppose in the first orbit, electrons are revolving in the circular path only. In the second orbit, there are two sub-energy states. Some electrons are in the circular path and some electrons are revolving in the elliptical shaped path. That's why second orbit or second energy level is said to be having two sub-energy levels. And by coming to third energy level, third orbit has three suborbits. One is circular, two are elliptical in nature. Okay, that was given by Sommerfeld. Next concept, dual nature of electron. That means particle and wave nature of electron. Yes, electrons are having particle nature as well as wave nature both. It was explained by De-Broglie's wave equation or De-Broglie's wave theory. For the first time, De-Broglie told that electrons are possessing these two properties, particle as well as wave nature also. In 1924, De-Broglie proposed that an electron, like light, behave both as a material particle and as a wave. Yes, in the 1924, De-Broglie proposed that these electrons are behaving in both the ways, like material particles as well as wave particles. This proposal gave birth to the new theory known as wave mechanical theory of matter. Yes, till then they have considered these electrons as only particles. For the first time, De-Broglie 1924 proposed that these electrons are possessing two types of properties, characters. Those are particle property as well as it is showing it is behaving wave like a wave also. So this is known as wave mechanical theory of matter. According to this theory, the electrons, protons, and even atoms, when in motion, possess wave properties. Yes, as though actually these are particles. They behave like a particle. But when these lightweight particles are microparticles in the motion with high velocity, they behave, they show, they possess wave properties also. So they are exhibiting dual properties. De-Broglie derived an expression for calculating the wavelength of the wave associated with the electron. Yes, as he told, electrons are not only particles, they possess wave nature also. So if they're possessing wave nature, then what will be the wavelength of this wave associated with these electrons? For this, he has given an expression for calculating the wavelength associated with the electrons. Let us see how it is given. According to Planck's quantum theory, energy of photon is given by, yes, we have studied that in the Planck's quantum theory, energy of the photon is given by the formula E is equal to h nu, and c nu value is taken as c by lambda, because nu is equal to c by lambda. So it can be written E is equal to hc by lambda. This is according to Planck's quantum theory. Energy of each quanta or photon is given by the formula E is equal to hc by lambda. The same energy in wave nature also it can be, particle nature also it can be given. According to Einstein mass energy relationship, energy of a photon is given by E is equal to mc square. According to Einstein's theory, one more derivation is given for energy calculation as per mass energy relation, that is E is equal to mc square. So these two formulae can be applied for the energy of electron, because electron is possessing wave nature as well as particle nature both. According to wave nature, the energy of the electron is given by the formula E is equal to hc by lambda according to Planck's quantum theory. The energy of the same electron is given with the mass energy relationship as by considering as particle. According to Einstein's formula, it is given as E is equal to mc square. So both are the energies of the same electron. Now we can equate these two, 1 and 2. What do we get? Here energy is given as hc by lambda. Here energy is given as mc square. So both are representing the same. Then it becomes hc by lambda is equal to mc square. So by this we can calculate lambda value. You can keep subject lambda so that we get it as lambda is equal to, what will happen? We cross multiply this. This lambda will come here. This mc square will go into the numerator here. Hc by mc square. Cc will be getting cancelled. So it becomes lambda is equal to h by mc, or lambda is equal to h by p, because mass into velocity is equal to momentum. We know the product of mass and velocity is momentum. So in the place of mc, we can write momentum p. This is called De-Broglie's wavelength equation. Lambda is equal to h by mc, or lambda is equal to h by p. This represents De-Broglie's wavelength expression or equation, where h is Planck's constant and m is the mass of electron, c is velocity of the electron, and p represents momentum of the electron. Okay, this is a De-Broglie's wavelength equation. Lambda is equal to h by p. Okay. Next, one more concept, Heisenberg's uncertainty principle. In 1924, Werner Heisenberg presented a principle known as Heisenberg's uncertainty principle, which states that it is impossible to measure simultaneously the exact position and exact momentum of a body as small as electron. Yes, The very small particles like electron, they are revolving at a very high speed around the nucleus. If it is in the continuous high speed velocity rotation around the nucleus, so it is impossible to calculate the momentum and the position both at the same time simultaneously and exactly. If we calculate them both at the same time simultaneously, we get some errors in their values. So this was explained by Heisenberg's uncertainty principle. It states that it is impossible to measure the exact position and exact momentum of a body like electron simultaneously. If we calculate both at the same time simultaneously, we get some errors in their quantities. That is, that error in that quantity is said to be uncertainty. So as it is what given by Heisenberg, it is called Heisenberg's uncertainty principle. Okay, next. If the uncertainty in the measurement of position of a particle moving with high velocity is delta x, delta represents some error. Okay, delta x means this is the uncertainty or error in the measurement of position of a particle like electron. And the uncertainty in the measurement of momentum is taken as delta p, where p represents momentum. We know momentum is equal to mass into velocity. So that can be written as delta mv also. Okay, if you consider these two, suppose the uncertainty in the position is taken as delta x, and uncertainty in the momentum is considered as delta p or delta mv. Then these two are related according to Heisenberg's uncertainty principle as delta x into delta p is greater or equal to h by 4 pi. This is a relation given by Heisenberg. This is called Heisenberg's uncertainty relation, where delta x represents high uncertainty in the position, delta p represents uncertainty in the momentum. The product of these two will be always greater or equal to h by 4 pi. Or, of course, in the place of p, we can write mass into velocity. So mass will be constant for any electron. So velocity might be changed. So uncertainty in the velocity is taken here. Now it can be written as delta x into m into delta v is greater or equal to h by 4 pi. Next, of course, here p represents mass into velocity, it can be taken. Okay, next, h is Planck's constant. Okay, thank you. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates and recorded videos. Thank you.